Okay, so where we're going to start is we're going to finish the three exercises from the section on symbolic arguments. And so exercise 3 was kind of a longer symbolic argument. I just had an example of each just to make sure if you can if you can understand what's going on with this long one, you'll understand anything else. So there were 3 steps I outlined for symbolic arguments. Anybody want to remind me of the first step that we have to do? Make our statements, for sure. Yes. So step 1 is always to identify your simple statements. So this one has 3. That's what makes this a little bit longer of a problem. So we're going to have a P statement, a Q statement, and an R statement. And so when I read through this, it says, if you lower the fat in your diet, then you lower your cholesterol. Okay, so P, we lower fat. I'm just going to abbreviate a little bit. The Q is going to be lower cholesterol. The next statement says if you lower your cholesterol, then you reduce the risk of heart disease. So we reduce risk. Again, I'm just going to abbreviate for space allotment. So there's step 1. I've defined my simple statements. Great job. Okay, what's step 2? Write the argument symbolically. So we're just going to take all these words and we're going to write them as symbols. Okay, so here's step 2. So the first statement, it's an if-then statement. So here's my arrow. It says if you lower fat, so that's P, then you lower cholesterol, that's Q. The next statement is, again an if-then statement. So here's my arrow. If you lower cholesterol, that's Q. Then you reduce your risk of heart disease, that's R. Then we have the word therefore, and I told you there was a cute math symbol for therefore. It's the 3 dots in a triangular pattern. And then the last one is another if-then statement. And this says if you do not lower the fat, so that is squiggly P, then you do not reduce the risk, then squiggly R. We want to know, is that what logically follows from the 2 premises? Okay. Then there's one more step before I do the truth table to determine if this argument is valid or not. And what was the third step that we do? I'm sorry? Yeah, we have to write the argument, the premises to the conclusion. Yes. So what we do here is we take some brackets and we take our premises. What do we link the premises together with? A conjunction, yes. So I have the first premise, if P then Q, and the second premise, if Q then R, and I want to know, and I'm running out of a little room here, so I'm going to do my error. I want to know, does that imply, okay, does that imply squiggly P then squiggly R? That right there is the new bit of information in this. The other stuff we've done before, but that's hard. Okay, so that's why I had you do this one for homework. Okay, so now what I'm going to do here is I'm going to start doing my truth table. I'm going to try to leave the argument on the screen as best I can, but I'll probably move this up because I want everybody to be able to see. So let me fill in my T's and F's here for my true. Oops, that should be a T. Sorry, everybody. Off to a crash and burn start already. So then 2 T's, 2 F's, 2 T's, 2 F's, and then we're going to alternate every other TF, 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 TF. Great. Okay, so I'm just going to take care of the stuff in the brackets first, then I'll worry about the conclusion. You might notice that we're going to need some squigglies, and maybe you want to just nail those down right now. That is fine. It doesn't matter, but I'll wait. I'm going to wait till the little later to do that. So first thing I'm going to do is P then Q, and hopefully it was fresh in your mind when you did this. Conditional statement is only false when it's true then false. Okay, that's our basic truth value, facts. So P then Q. So true then true is true, true then true. So we got a true then false is false, true then false is false. And then the last ones all start with a false. So their logical result is true. I'm next going to do my other premise, Q then R. Okay, Q then R, same thing. True then true is true. true then false is false, false then true is true, false then false is true, true then true is true, true then false is false, and then the last two are going to be true. Again, just for room's sake, what I'm going to do is I'm just going to put some brackets here and I'm going to put the and sign in just so you know that this is my premises. I'll write the word premises. That way there's no, I'm just trying to save a little room on my truth table headers. And the statement's true and both are true. And I'm going sort of speedily through this because I asked you to do this for homework. And that way we have time for questions when they arise. So true and true is true on that one. True and false is going to be false. False and true is going to be false. False and true is going to be false. True and true is true. And then true and false is false. The last two are both trues and trues. So there we go. So there's my premises. Okay, got the word premises on it, so we've highlighted that column. We're going to come back to that in just a minute, but before I can do anything with the premises, I need to do a truth column for my conclusion. The conclusion is squiggly P, then squiggly R. Okay, well, you can see that this problem was last just because it has the most columns, so it was a little bit of busy work here. I don't always like all the extra busy work, but it was necessary on this one. So squiggly P is just the opposite of P, so that's going to be 4 falses and then 4 trues. Squiggly R is going to be the opposite of R, so it's going to alternate false and trues. And now I'm going to do squiggly P, then squiggly R. Okay, this is the third conditional statement. We're actually going to do one more conditional statement. Conditional statement's false only when it's true then false. So here we go. False then false is true. False then true is true. False then false is true. False then true is true. True then false is false. True then true is true. True then false is false. And true then true is true. And at long last, okay, so this is my conclusion. And so at long last, I'm just going to use a big arrow here. What I want to know is, does the premise always imply the conclusion? And the answer is this will be valid. Yes, it does, if every row has a T. If we even come to an F, we can then say, okay, this is an invalid argument. There's a hole in this argument right here. So here we go. The premises, then the conclusion. True, then true is true. False, then true is true. False, then true is true. False, then true is true. True, then false. Uh-oh. Eyes on that. False, then true is true. I'm going to finish this off. True, then false is false. True, then true is true. So we can see, I'm just going to put a little asterisk. Because of those two F's, what I can now say is that this argument is invalid. Okay? The premises, the given statements, do not always lead to the conclusion that if you do not lower fat, then you do not reduce the risk of heart disease. All right, so that was a very long one. Okay, so it's good to work through things like that. I probably won't put ones that super long on the test, but it's good to know how to handle that. All right, so then the last thing we did, I only had time for one example, so I apologize for that. But I don't know that this is definitely the other stuff I think is more difficult. This was just using the table to figure out which conclusion was appropriate. And so what I'm going to do is I'm going to do the first 2 steps that we just did. I'm going to define statements. I'm going to write it symbolically. Then we're going to go up to the table and compare and say, what is the valid conclusion that I can make here? So exercise 4 says this: I will attend the concert or I will attend the volleyball game. I will not attend the concert. Therefore, what's the conclusion? Okay, well, let's do this. P, Q. Again, it does not matter what order you define P and Q, you will come to the same conclusion. Okay, so don't freak out about that. So P, I'm going to attend the concert. And Q, I'm going to make attend the volleyball. So the first statement, the first premise is I will attend the concert, so that is P, or it's a disjunction, I will attend volleyball, Q. The second one is I will not attend the concert, so squiggly P. And so therefore, and now this is where we're going to turn our attention. We're going to go up to the table. So just I'm gonna move my sheet so you can still see yours. I've got P or Q and squiggly P. I want to know what the conclusion is. So I'm looking up here. Do we see that form of the argument up here? Which one is it? That is a mouthful, right? Disjunctive reasoning. Try to spell that 3 times fast. Yes, it's this one right here. We've got P or Q and then squiggly P, or you can see it works with squiggly Q either. And then the conclusion here is conclusion is just the statement Q. So I'm going to go back down here and I'm going to say, okay, that means that my conclusion according to the table is Q. And now I'm going to write that out. Therefore, Q. Therefore, I will attend the volleyball game. My daughter did enough volleyball that should probably say the volleyball match, but I was probably in a hurry when I did this. So sorry about that in case you're a volleyball player and are offended. Not meaning to do that. All right, so here we go. Last one, exercise 5. It's the same sort of thing. You know, maybe this one turned out a little better for you. So here we go. Exercise 5 says if the students get their requirements done early, then they do not take the math test. And then the students took their math test last semester. Okay, so here we go. So statement P is going to be the students get their requirements done early. So I'm just going to write requirements done early. And then statement Q, well, this says they do not take math. They do not take math their last semester. So remember, we always define our simple statements positive. So they take math last semester. And so now I'll write this argument in symbols. So here we go. If the students get their requirements done early, so that's P, then they do not take math their last semester, squiggly Q. Then the next one is students took math their last semester, so that's Q. So therefore, all right, so we've got P, then squiggly Q. We've got the negation of the guy. We got plain old Q right there. So let's go up here. So this one, I know it might not necessarily look like it, but we've got P then Q. Okay, so there's my conditional statement. And then this right here is the opposite of the conclusion. Okay. So whereas this does not say P then Q, I know it says P then squiggly Q, but the reason this fits that pattern is because this is the negation of the conclusion. So it's in the same format, even though there is that squiggle in there. Okay, so then what is the conclusion? The conclusion is the negation of whatever P was. So we're going to go down here. We're going to say, okay, the conclusion is the negation of whatever P was. And so that means, therefore, the students did not get their requirements done early. So I'm just going to abbreviate that. Therefore, the requirements were not done early. So before I end this, remember I said on the test, I'm not going to make you memorize. If I give problems like that, I'll give you the table to compare things to. Okay, so I don't want anybody freaking out that I've got huge expectations on that. I try to be reasonable on things like that.